Let's look at the first example. Consider the straight line L in the Cartesian plane with equation 2x plus y as shown. Determine a vector equation of L using point 5, 0. First of all, if we think about this vector equation 2x plus y equals 10, and I rearrange it to y equals negative 2x plus 10, then you can see the gradient of the line is negative 2. And that's important because if we're going to be looking at vector equations, then they have to be parallel to the line. Okay, so position vector of 5, 0 can be written as a vector 5, 0. We know that the gradient of the line is negative 2, so we can rewrite that as 1, negative 2, meaning write 1 down 2. Or if you're thinking about your rise over run, write 1 down 2. So my equation of R is going to be 5, 0 plus K, lots of 1, negative 2, which is going to be 5i plus k, I minus 2j. Part B, determine a vector equation of line L using the point 0, 10. So 0, 10 as a vector, and vector parallel has the same gradient. So that means we can use our 1, negative 2. I'll label this R2, is going to be 0, 10 plus k times 1, negative 2, which is going to be 10j plus k, I minus 2j. Now note, position vector may be any point on the line 2x plus y equals 10. Last part, determine the position pxy using each of your equations when k is 1. So my first equation was 5i plus k, I minus 2j. So when k equals 1, I have R1 is going to be 5i plus I minus 2j, which is 6i minus 2j. My second vector equation was 10j plus k, I minus 2j. So when k is 1, I'm going to have 10j plus I minus 2j, which is I plus 8j. Now, pxy is 1 unit to the right and 2 units down from the chosen initial position vector. So P1 is 6, negative 2, and P2 is 1, 8, and that's just from those equations. And you'll also see the negative 2 and the 1 for 1 to the right and 2 units down.